In this video, we're going to be tackling the infamous LeetCode threesome. And yes, I say infamous because the name is totally unhinged. The title of this question did not need to happen. That is besides the point. The whole entire point of this video, if you don't remember anything about this video, is don't triple loop in this problem. Do not use 3 for loops. If you can keep it under 3 for loops, you're good to go. You've passed the interview. But if you go into triple loop territory, you're gonna fail. You're gonna have a bad time. But how exactly do we solve this algorithm with no 3 for loops when the whole entire point of it is to find a threesome? We're going to use algorithmic patterns. And there's more than one that you can use. You can use a 2-pointer as well too, but I'm not going to use a 2-pointer because in this video, we're going to solve it with what's called no sort. We're going to use no sorting methods. In this video, we're going to be using 2 hash sets. But what is it about this data structure that allows us to solve this problem in record time? Well, first things first, a hash set does not allow us to add duplicates. So in this example, we would only have 1 sheep because we are not allowed to add the same thing to a hash set. We cannot have duplicates. Also, hash sets are very good at finding things. If you need to search in a data structure, if you need to find something very quickly in a data structure, a hash set is going to allow you to do that in constant time, literally the fastest time possible. But let's just go ahead and dive straight into the algorithm. How exactly is this even going to work? Let's just break down the problem step by step. So you probably know this already, but if you don't, we're trying to find all of the 3 numbers, the threesomes that add up to 0. And in this case, those 3 numbers are going to be -1, 0, and 1. And it's also going to be -1, -1, and 2. So -1, -1, and 2. If you add all of those numbers up, it is equal to 0. So we're going to solve this using 2 hash sets. And with that in mind, let's just go ahead and initialize our 2 hash sets. These brackets right here are going to just be our 2 hash sets, and they're pretty much indistinguishable from arrays, but they just have those unique properties that we talked about before. So next thing that we're going to do is, because it's an algorithm, we're going to have to do some type of iteration. No surprise there, but we're going to have to do this in 2 for loops. So we're going to initialize 2 for loops. Remember, you never want to initialize 3 for loops. So we'll go ahead and initialize 2 for loops, 1 on the first number and 1 on the second number. So what exactly is going to happen next with these 2 for loops? Well, nothing special, because these 2 for loops are going to operate just like any other 2 for loops in existence. The second for loop is going to iterate through all of the numbers. The first for loop is going to inchworm its way up, and this process is going to repeat. The second for loop is going to iterate through all of the numbers, and then the first for loop, you guessed it, is going to inchworm its way up. And this process is going to repeat till we reach the end. But what type of logic is going to be going on the inside of these 2 double for loops? Well, think about it like this. For loops are pretty much fancy pointers. And if we have 2 for loops, we're already pointing at 2 numbers. So we can find the third number. We're pointing at -1 and 0. Remember that. And let's think back to our high school geometry days. If we have -1 and 0, we have -1 and 0, we have 0 on one side of a triangle, hypothetically, and we know that all of the numbers add up to 0, what is going to be the third value? Well, it's going to be 1. And that's pretty much the whole entire process that we're going to do as we iterate through this array. Now you may be asking yourself, well, where exactly do these two hash sets come into play? What's going to happen is at each place that we iterate, each time that we move in our second for loop, we're going to check if we've seen the third element in the triangle, so to speak. We're going to check if the missing number exists. If it doesn't exist, which it doesn't exist in this case, what we're going to do is we're going to add it to our hash set. But we need to go through one more iteration because the next iteration is very important. And what's going to happen is that the second for loop is simply going to move up. That is our next iteration. And we're going to do the same exact thing. We have two numbers here, and we're going to check, has any number that we've seen add up to 0? Are any numbers that exist within the hash set the magical third number that's going to give us 0? And we have -1, 1, and we have 0 in the hash set. This indeed is a threesome. This is one of the numbers that we're looking for. So you guessed it, we're going to go ahead and add it. We're going to add -1, 0, and 1. And the reason we're going to add it to a hash set is because we don't want to add duplicates. So I won't bore you with going through every single iteration, but I'll just show you what happens when the algorithm finds the second set of numbers. It's going to iterate to 2. The 2 does not complete the complement, so we're going to go ahead and add it. And then once we get to the 1, that is indeed the complement, we'll go ahead and add -1, -1, and 2 to our second set of the threesome. So we're going -1, -1, and 2. And that's pretty much it. So let's go ahead, let's hop over into IntelliJ and let's solve it. So we are inside of IntelliJ, and the first thing that I'm going to do is create a brand new Java class. I'm going to call this solution. And this solution class is going to house the method that's going to contain our algorithm. So it's going to be public, of course, and we're going to return a list of lists. And the nested list, the list on the inside, is going to contain integers, and those are going to be our threesomes. That's going to be our triplet. And let's go ahead and import this class. So the actual method name is going to be threesome, and it's going to take in an integer array of nums. So let's go ahead and get started on our data structures. Remember that we're going to have two hash sets. One hash set is going to be there to check for duplicates, and the other hash set is going to be there to check for scenes. We'll talk more about the second hash set here in a second, but this is going to be the hash set that's going to check for duplicates. We've got our data structure figured out. Let's go ahead and create our first for loop. So notice something interesting about this for loop. The I is less than nums.length minus 2. What's that about? Well, we're actually going to stop the first for loop one place from the end because there's not even going to be the possibility of a triplet once we get to that point. And that's the reason that we have a -2 here. So the next thing that we're going to do is we're going to go ahead and add our second hash set. And this is going to be the hash set that's going to check for scenes. Whenever we need to search for the complement, the magical third number, this is the hash set that we're going to use. Now what we're going to do is we're going to initialize our second for loop. We're going to be starting at the second element compared to the first element of the first for loop. We're also going to go ahead and get rid of this -1 because with that -1 there, the test will not pass. So make sure it's just nums.length and not nums.length minus 1. Next thing, we need to find our complement. Remember, the complement is just the magical third number. And with the complement, we know that nums I, let's say nums I and nums plus j. So nums plus j plus the complement is equal to 0. But if we do a little bit of magic, we do a little bit of algebraic magic, what we can do is we can just make it so negative nums I minus nums j is equal to the complement. You don't have to rack your brain figuring out how to find the complement. It's just abstracted for you. So IntelliJ has just taken care of a very important piece of logic. And what this if statement does is it checks for our complement within the hash set. And if we found our hash set, that means we have a threesome. We found the magical third number. We need to store it within a list. And you can do that in many ways. But first thing that I'm going to do is I'm just going to do a little bit of abstraction. I'm going to pull out the nums I and the nums j and store them under single letters just like this so that we don't have to keep typing this out over and over. I'm also going to store the complement as C because we're going to have to use what's called no sort here right now. So we're going to store these three numbers. We found the data that we want. We found the threesome, the triplet, whatever you want to call it. Now what we need to do is we need to store it within a list so that we can put it in our broader list. How exactly are we going to do that? Well, there's many ways. And we're going to use what's called no sort. But you could easily do this with any regular sorting method provided to you by Java or any major framework. But there is a chance that the interviewer at whatever company that you're working for may ask you to do without a native sorting method. So what we're going to do is we're going to use math.min and math.max as a very clever way to sort the triplet numbers. And I'll show you how to do it right now. So what we're going to do is we need to find the smallest number within the triplet. And the clever way to do that with math.min is to take the math.min of A and the math.min of B and C and finding the smallest number within the triplet. And that's exactly how you do that. So next thing that we need to do is we need to find the middle number. But how exactly are we going to find the middle number? We find the middle number by doing this. We're going to sum A plus B plus C, all of the numbers. Then we're going to subtract the minimum and the maximum, and that's going to leave us with the number in the middle. So we'll say math.min, then we'll take the math.min of A, and then the math.min of B and C to give us that minimum number. So we'll say math.min, B, and C. Then what we'll do is we'll take the math.max. The math.max is what's going to give us the maximum out of all three numbers. And the way that we find it is exactly the same. It's just the math.max instead of min. So we'll say math.max of B and C. Finally, we've got the middle number. That was quite an undertaking. So now that we've got the middle number, all that we're going to do, and I need to go ahead and delete one of those parentheses right there. We need just two parentheses at the end. Now what we're going to do is we're going to find the math.max, and we just found the math.max, so it's going to be pretty easy to do. We'll say math.max of B and C. So we'll go ahead, close this out with a semicolon, and we can finally add this to our hash set. And you may be asking yourself, why did we go through all of that to just sort it when the hash set is going to take care of duplicates for us? Well, this is going to be prevented. Just a blatant copy is going to be prevented by the hash set. But what the hash set won't prevent is if, let's say, the numbers are switched around. We want all of these threesomes to be unique. So that's the reason that we went through all of that just to sort it. So we finally got this taken care of. We can just go ahead at the bottom here and use scene.add if we don't find the complement to go ahead and add it to our hash set. And last but not least, we're going to do the return. We need to turn our hash set into an array list, and that's pretty much it. So I'm going to grab all of this code right here, and let's go ahead, toss this into LeetCode and see what we get. I need to get out of full screen here. Go ahead, bring over the browser, and we'll go ahead, toss this in, move this over. Let's run our test and see what we get. Thank God it is accepted. Go ahead, smash that submit button. Our time complexity is not going to be linear. This problem is notorious for being pretty slow, but it's still passable. Our time complexity is n squared. We beat the dreaded triple for loop, so we're good to go. And our memory is linear as well too. Hope that you guys enjoyed this. If you did, make sure to smash that like button, smash that subscribe button. And as always, thank you for watching.